If you're a replay viewer, thank you for joining. I appreciate this and spending some time with me tonight. I am Dr. Tamitha Scove, and I am a space weather researcher and forecaster. And I see people joining me. Thank you. Appreciate you guys joining tonight. I have some really cool news to share with you this evening. We do have a very active sun right now, and we have a new solar storm that is being launched, or that has been launched earlier today with a big flare. And it's going to be Earth directed, and it looks like it's going to give us some new aurora for New Year's Day and New Year's Eve. So thank you all for joining. I am a space weather researcher, as I mentioned earlier. Hi there. Thank you, Michelle. Appreciate you joining in. And during my, just so that you know a little bit about me, during my day job, I spend time telling NASA, NOAA, and other government agencies what space weather is happening, where they end up having problems with their spacecraft, and how to mitigate these problems. And then in my off time, I like to be able to share this information with you guys. Thank you for inviting followers, Michelle. I appreciate that. I like to share this information with you guys so that you have a better idea of what space weather is all about and how it can affect you, because it can affect you on a daily basis. And as our technology continues to grow and advance, we are going to become more dependent upon space weather and how it affects us. So if you know anybody who is a GPS operator, has, you know, like Fitbits, or is a UAV drone pilot, that type of thing, that uses GPS in their daily lives, or they're a ham radio operator, or they are an aurora photographer, or they just happen to love staring at the sun like I do, then please swipe up on Android or swipe right to left on your iOS device and click share. And if this is your first time tuning into one of my scopes, hopefully I'll give you enough eye candy to keep you quite excited and let you know that your star is a very active star, and it does a lot of things that affect Earth on a daily basis, and you can be in tune with that information. So let's see, don't stare at the sun, right? I do it quite often. I know I should be blind by now. Hey there, Mikhail, K7SKE here. Thank you for joining us. A lot of ham radio operators in the house. I appreciate you guys joining. Hopefully you're having a wonderful holiday and are getting ready for New Year's Eve. And if you are able to catch aurora, whether it be in photographs or actually in real time, if you can catch it on New Year's Eve, it's supposed to be very, very good luck. There are a lot of proverbs and actually even Japanese sayings that if you actually can conceive under the aurora, then your baby is supposed to have a lot of good luck. So hopefully there will be a lot of celebrating this year. And thank you guys for joining. I see Cyclism 15, thank you. Is flare activity more active than normal? Not more active than normal for the declining phase of the solar cycle, but this is, it's not all that often that we get a really big event that occurs right in what we call the Earth strike zone, which is what happened here. So KCONET, visiting in LA, visiting Los Angeles, or visiting Louisiana. Either way, thank you for joining. I appreciate that. And yes, you can see this region right here. I've got it up right here. This is the big flare that we're watching, and it did launch something right in Earth strike zone. The flare that it lit off, you can see it right there. It wasn't that strong of a flare. It was only an M1.9, which is strong. Let's see, had a good run on 50 hertz 2 evenings ago. Yes, good. But you're going to start having problems with that, and I'll get more into that in a few minutes. Hey, too soon to compare to the 1220 solar storm? Yes, definitely too soon to compare. And also that 1220 solar storm had 2 CMEs that were back-to-back, 2 solar storms that were back-to-back. This is just one, but man, it's right in the middle of the Earth strike zone. So let me go ahead and get to it, guys. This is region 2473. It has been an M-flare player right since it entered Earth view, actually even since before it entered Earth view. Back, we were watching it on the backside because we happen to have a sun watcher, a big satellite that's sitting on the backside, and it's watching for flares on the backside. So we knew this guy was going to be busy before he even rotated into Earth view, and true to form, he's been firing off M-class flares pretty much ever since he got on the disk. They haven't been huge M-class flares, but we have had some low-level radio blackouts. So you amateur radio operators, if you've been having troubles on the bands where you're communicating with somebody and then the bands just go dead and it's all this static and nothing else, and you're going, what happened? That was because we've had one of the solar flares happen probably from this region right here, 2473, and you can see it. It's like little paparazzi flashbulbs going off. So basically earlier today, we had this huge eruption. You can see it right there. It was a big, long duration flare. We had a lot of what we call post-eruption arcades. and this dimming regions, and I'll show you that in a minute. And yes, it's going to hit New Year's Eve. So, and it'll actually hit maybe a little bit before that. We have two models, and I'll show you a little bit of both of them. One of them is NOAA's model, one of them is NASA's model, and they have about a 12-hour difference in their prediction time. How long do these last, and how do they affect the ham bands, K2 LTE? Thank you for your question. These will last about, when the solar storm actually hits, this will last about 24 to 48 hours typically. And how does it affect the ham bands? It will just make the ham bands so noisy, especially on the night side, that it will be very difficult to deal with it. So on the day side, you have these big flares that you have to deal with and radio blackouts. And on the night side is where you get a lot of the major issues with the solar storms once they hit. Now the flares are just basically light and radio emission. When you see them, they happen, they reach Earth. That disturbance reaches Earth within minutes of it actually happening on the sun. But the big eruption, the solar storm that's launched, is much slower. And so that actually takes several days to reach Earth. So just because we saw this flare here right there, it's not over. We had that radio blackout earlier today, but now there's something coming towards us, and I'll talk more about that. Thanks, Dr. T, for explaining 81E. You're welcome. I'm glad hopefully it's making sense. And yes, if you have more questions, please roll them up. And if I miss them, keep putting them up. And if I still miss them, then nail me on Twitter or something like that. And well, nail me, that's not the right word to use, but ping me on Twitter and I will answer your question. So, okay, so that's the big region right here. We do have two M-flare players. This is region 2472, but it's not doing all that much. We really are keeping our eyes on 2473 because that's the big one. And it doesn't look like this guy's done yet. Even though he's let off a nice, huge flare, you'd think that would quiet him down for a little while, but he's still very active. So we might have more problems as time goes on. So let me switch from that to where you can actually see the eruption. Here is another view of the event. Well, I'm getting a brownout right now. Hopefully you guys aren't, hopefully we're not losing power. I just saw our lights shutter down, so that was kind of scary. So you can see the same region right here, and sorry about the little problems we had with the data telemetry. But do you see those hot ribbons that opened up there? You also see some dark dimming regions on either side of this once it flares. I'll show you the flare again. Right there. See the dimming? See the dark regions there and there? That shows you the extent of that solar storm, so it's actually pretty wide in terms of eruptions as far as they're concerned. So that definitely shows you that it's in the Earth strike zone. We also have these really post-flare loops, a lot of beautiful arcades, and that means that this structure is very coherent, which means it most likely will give us a lot of really strong, intense fields and very, very predictable once it hits us, once we hit the core of the storm. So that's what we're expecting there, and I'll get you off of this particular thing, but I'll show you what this flare actually looked like when we actually looked at it from X-rays, and that was this guy right here. So this is an X-ray flare. I'll push this out in front here. Hopefully you can see this and it doesn't dim me out too much. So this is our X-ray flux meter. This goes from December 27th all the way to December 30th. This line right here represents our M-flare threat level. So anything above this line gives us radio blackouts. Okay, and as you can see, we've got one big peak. Most of our peaks have been C-class flares and smaller, near M-class, but not quite, but very short. This one was a hugely eruptive flare. You can see how long it took to decay. This is the flare that caused that eruption. And as you can see, even on the decay, it continues popping off little flares. Pop, 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 pop. So you can see we're still getting more flares, and that tells us that this thing is still unstable and could erupt again. And it's still close enough to the Earth strike zone that we could start seeing, we could still see yet another solar storm from this thing. Will you be updating statuses periodically from now till then? Please and thank you. Yes, I'll do my best. Periscope is hard for me to do because I have to prepare, and I have a very horrible commute for my work. So I'll do the best I can on Periscope, but definitely on Twitter. Twitter and Facebook, I'll definitely do it. Twitter is a lot faster. I can do a lot more updates on Twitter much more frequently. And of course, when the storm actually hits, I am usually slamming people's timelines with all the Aurora photos because so many people report in and let me know where Aurora is happening or what the ham band conditions are, stuff like that. So I retweet a lot of that stuff so you guys can know if you want to go out and do Aurora hunting, or if you are a ham radio op and you're worried about your rig because it's not working properly, stuff like that. I keep you up to date on when and where the effects are happening. Does the sun have its own magnetic field? Yes, it does, absolutely. That's why these things can be so powerful. It's kind of like having, the Earth has its own magnetic field, and if you think of that as like a fridge magnet, and then you think of the sun spitting off a storm, and that's like a fridge magnet. When those two magnets come together and they click because they're attracted to each other, then they can pump all sorts of energy into the Earth's system. Is San Francisco Bay Area too far to south to see aurora? For a small storm, yes. For big storms, no. As a matter of fact, earlier this summer, we saw aurora. I saw a picture of aurora that somebody tweeted to me that was seen south of San Jose. So if you know where that is, which is an hour south of San Francisco, that lets you know it's unbelievable how easy it is to see aurora. What about Michigan? Absolutely. You'll probably see aurora in Michigan if you get out of city lights, you'll see aurora in Michigan probably with this storm, and you definitely saw it with the last storm. We saw aurora as far south as Colorado and Iowa, may have even gotten reports in Oklahoma. And I just missed a question. I apologize for that. So go ahead and shoot that question to me again. So anyway, so here's that big eruptive flare, and we're going to expect to see more. So you amateur radio operators, on the day side, expect that you're going to see more ham radio blackouts. Please tell us what a triaxial fluxgate magnetometer is. Triaxial just means it measures a magnetic field in 3 directions. So it can resolve a fully spatial, a full vector, right? It can give you magnitude and direction of any of the direction of the magnetic field in any basically in space. It's not just 2-dimensional. A fluxgate magnetometer is a particular kind of magnetometer that's got both sense and drive electronics in there. It's a very small, compact magnetometer that actually has coils that are put around like a ring, and you coil this metal, make it like a metal coil around a ring, and then you have drive electronics that actually are able to sense how the shift in the magnetic field based on that. And I won't go into the details, but that's basically what a triaxial fluxgate magnetometer is. It's measuring the flux of the magnetic field through this little coil, okay? If you need more details, definitely, get a hold of me later. I worked with those types of magnetometers in my grad school career, so I know a little bit about them. Does the Earth give off flares? No, not the kind of flares that the sun gives off. That's for sure. Okay, so let me move away from the X-ray flux. What I will show really fast, I'll go ahead and put this. Hang on. Put it back to a pretty sun picture for the background. Let me show you really quickly. Let's see. Okay, yeah, I wanted to show this to you. So this is a still shot. I have this posted up on Twitter right now. This is before the eruption. This is so you can see it in multiple colors what's going on. Remember I mentioned the dimming regions? Well, there they are right there. You can see where it dims, so you can see how wide this structure is. And then you've got the post-eruption arcades or loops. This shows where the main body of this thing is. It's actually a solar slinky that's most likely oriented kind of this way. So the axial field points up like this, and it comes off as a slinky coming towards you like that. And then I don't know if you can see this, but there's actually jets of plasma. In this particular color, this is 304 angstroms, you oftentimes see a lot of the eruptive plasma. And you can actually see jets shooting off. Here's kind of the hot part of it right there, but you can actually see it shooting off. So anybody who wants to go to the SDO website can see some gorgeous pictures of this eruption, and there's neat things to look for in every single wavelength that we look at. So these false color images really, each of them, this is a perfect example of telling you how these different colors tell us different information about the same eruption. Hopefully that gives you some insight. And also, just in case for those of you who are wondering what this big black thing is up here, this is a coronal hole. This is a polar coronal hole. That's actually some of the wind we think might actually be helping to push this thing and make it go faster. So that's that right there. Now let me go and show you. This is why we know it is Earth directed. I'll press play here. This is a coronagraph. It's a difference image. And what you're looking at is the sun is like a little hole right here, area right here. This is an occulting disk that blocks out the sun's light so you can see its atmosphere, the corona. Now what this is a difference image, so that's why it's kind of gray and grainy, is that we're subtracting one image from another. But what's important about this is that you can see what's called a full halo. When that eruption hits, boom, right there, it causes this disruption that looks like it's almost all the way around the whole sun. You see that? It's like 3/4 of the way around the sun. We call that a partial halo. And when we see partial halos, that means the eruption is coming right at you. And so it's surrounding the sun as it comes towards us. So this is what, it was a really good partial halo. It gave us a good estimate of the speed because we check this area to see how fast this thing is moving. And that's what gives us our prediction models, which I'll show you here. Let me kill this for a second. And I'll go to, now here's the two prediction models. So we're a little bit confused as to which model is right. Okay, here is a freeze frame of NASA's version of the model. This is NLL. This is all density. And what I've done is I've taken a freeze frame of the solar storm. You're looking down at the north pole of the sun, and here's Earth here, and here's west and east. So north is kind of pointing out of the plane of the page, and hopefully you can see this. But here's that solar storm, and this is also posted on my Twitter feed and on Facebook right now for those who want to see it. And you can see that solar storm right there hitting Earth. This right here from north to south is like a cut right at the Sun-Earth line. So it cuts right through the plane of this thing, so you can see how long it extends both north and south. So this thing looks like it's going to hit Earth, and then when it passes through, right past through the center point of Earth, it's going to make an imprint like this. So it's kind of like a big splash. It makes this big footpoint, and it's going to completely envelop Earth, which is right there. So when that happens is basically the beginning. It's 12:31 at 0 UT, which is 0 Zulu time. So literally at midnight on the 31st, right on New Year's Eve day. Do the speeds of solar flares vary? Yes, the speeds of these solar storms vary dramatically. Remember, it's the solar storm. These are the CMEs, the coronal mass ejections that come out and hit Earth. The flares are only, those travel at the speed of light, essentially. So those take about 8 minutes. These take days. They're much slower, but they're much more intense. These are the structures that cause Aurora, that cause ham radio operation issues for days at a time and cause Aurora. Now let me show you what the NOAA model shows us. So that one, remember, was the beginning of New Year's Day, or New Year's Eve day. And this one, here we go, here's NLL again. You'll see, here's the sun, here's Earth. You see that big structure coming out? This is the official version of NLL. And you can see it actually hits here on right about noon on the 30th. So now we have two different models, one from NOAA, one from NASA. The NOAA model is saying this thing is very intense, that it's moving a lot faster. This is the speed down here, that's density. So it's actually showing that this thing is hitting a lot sooner, which means it's actually faster and stronger than the NASA model predicts. We will get a stronger storm if we end up getting it hit by this structure on the 30th. And all of NOAA's predictions are based on this speed and a stronger storm. If it's more like the NASA prediction, then it won't be quite as strong, and it won't give us quite a strong aurora, but most likely anyway. But this is predicting a pretty strong shock. So for those of us who are aurora hunters, I'm sure we would much prefer to have this faster version of the model be correct. So, okay, so let's see. Now I've shown you that. I'm trying to think what else I wanted to show you. I think right from here I'll go to my 5 days. Let's see. Whoops. Hold on. I got to remember where I put them. Okay, not you. You. Up, please. Up. Oh, that's the model. There we go. Sorry about that, guys. Takes me a second. Okay. Oh, one thing I mentioned, I meant to mention. One of the things that this structure is driving is a shock. And this shock wave is also launching solar energetic particles. Now, we probably had some when the actual solar storm was launched, but we also are having it being driven by this big shock wave in front of it. And this is actually an older picture now. There are more energetic particles than there used to be. But what they're doing, if you look at this map, it's actually causing an enhancement up at high latitudes. And this enhancement, this solar radiation storm that's penetrating, is actually causing issues for GPS navigation right now. Amateur radio, if you guys are at high latitudes, you're going to have problems with communicating. And also airline flights may have a few issues, especially for those people who are flying, let's say, at high altitudes, high latitudes over the poles on the big transcontinental flights. You guys are actually getting extra doses of radiation, and you'll probably have that over the next couple days or so. Here's part of the radiation storm. You can see these particles going up here, and these are actually reaching higher. We're almost 3/4 of the way to our S1 radiation storm level. So we're keeping an eye on this. So any of you guys who know high-risk passengers, let's say they're chemotherapy patients or they're pregnant and they don't absolutely have to fly, they might consider delaying until after this solar storm hits, because most likely this radiation, this enhanced radiation, will die down at that time or within the next few days after that. HF is pretty quiet in Quebec. I mean, quiet. You have a quiet noise floor, you're just not hearing a lot of people. And if that's the case, it could easily be this issue, especially anybody who's trying to get communication over the poles. Now, this is not a huge radiation storm. It's just at enhanced levels right now, but it is an issue for those of you who are high-risk passengers on long international flights. You might just at least take this into consideration. I missed that about the north, but I missed that. Let's see. Do the flares affect frequency below something? Below 1 megahertz? The flares they affect all the way down, but I think with the ham radio bands, we just look at what 5 megahertz and below, or 5 megahertz and above. Let's see, where do we look? Well, no, we look even further. But yes, it'll always affect. In this case, it'll always affect both the flares, which is what you're seeing here in this purple region. That's in the middle of the. This is actually the day side when you see it here and here. So it means noon is somewhere right. When I took this picture, that noon was somewhere around New Zealand and stuff. But that purple region in the middle of the globe is low latitudes is due to flares. The stuff at high latitudes here, this is due to the proton radiation storm. So yes, all of it combined, it does affect the low frequencies. This is in megahertz. This is affecting the low frequencies at 1 to 5 megahertz far more than it affects the high frequencies at 25, 30 megahertz. So it will affect the low frequencies first. What level of storm expected? Yes, NOAA is predicting a KP of 7. That is true, especially at high latitudes. As a matter of fact, I'll get to that now. Let's see if I can zoom in for you. Okay, hopefully you can see that. Is that hopefully good enough, guys? Okay, so this is the 5-day solar storm conditions and aurora possibilities for the next 5 days. At high latitudes, that means about 60 degrees and north. We're going to expect active conditions with a minor chance, about 25% chance of a minor storm on the 29th. On the 30th and 31st, NOAA is expecting a major storm. Whoops, sorry about the phone. Hopefully that picked up pretty fast. Okay, good. Come on, pick up the phone.
Call from South America.
Sorry. It's my husband's work phone, so. Okay. So on December 30th and December 31st, we're expecting a major storm. NOAA is giving us about a 70% chance of a major storm at high latitudes. At mid-latitudes for the December 31st, we're expecting a minor storm with about a 20% chance of a major storm on the 30th. Now, I do believe that well, typically these models their predictions are a little bit fast. They expect that these solar storms come in faster than they really do. Real life rules, yeah, I know. What can I do, right? I try to do all these things that do not disturb on my phone and everything else like that, and then of course I forget the landline actually has to ring, and I don't take the phone out, so sorry about that. Does solar radiation attenuate as it gets farther away from the sun? Yes, it's a 1/r² rule as far as I know. It's just like any other kind of light illumination. It always kind of falls off with distance. It's just that the sun is so incredibly intense that we can actually still get an immense amount of radiation. And that's true for flares too. If you, for instance, we have the solar probe and the solar orbiter that are on their way to the sun, or will be on their way to the sun soon, and we've had to do some real work to understand how that radiation and heat, especially, is going to affect these orbiters and these spacecraft clear up to, at distances that are closer to the sun than Mercury. So we've really had to worry about the space environment, and that's the biggest issue, believe it or not, is actually heat. It isn't light or even solar flares, it's the heat. We have huge heat shields on these spacecraft because of that. So Mercury must get hit hard, absolutely. I think one of the biggest things that we were surprised about was that Mercury actually had an intrinsic magnetic field and had, I think we had it even a small little teeny tiny bit of atmosphere, because we would expected it just to be completely blown away with the amount of intensity, just not the solar wind, but also the heat coming from the sun and being so close to the sun. Mercury surprised us quite a bit. Anyway, so getting back to this. Okay, so that's our solar storm outlook. So you can see there are great aurora possibilities over the new year. We'll even on January 1st, we will have active conditions with a small possibility of minor storm. And I will post these on Twitter and on spaceweather.tv, as well as on Facebook here in the next day or so. Now, getting to the solar flare and particle radiation storm outlook for the coming week, hopefully you can see this. Now, because of region 2473, we do have about a 50% chance of an M-class flare pretty much over the entire week. While this thing is still visible, and it will be for the next close to 7 days, we are worried about these M-class flares. We also have an X-flare risk of about 10%, and that again will continue until this region rotates out of view. Now we do have elevated radiation right now, and we have about a 10% chance of yet another radiation storm from this same region, and that will continue over the next few days. We're expecting that once that solar storm hits, though, that the elevated levels, and it may even reach S1 storm level, but it will probably die down shortly after that once that shock wave from that storm passes us, and we should be back down to pretty much normal levels at least by the second, maybe a little bit earlier. So those of you who are affected by the radiation storm, take heart. Hopefully by the weekend things will be back to normal. So if you have any contests, if you amateur radio operators or anything like that, hopefully things will be just perfect or back to reasonable levels by the time you start contesting. So I think outside of this, I think that's it. Yep. Let me see. Now I'll go back here and see if there happen to be any questions on Twitter and questions that you guys have for me. Anybody? Let's see. My internet's not fast enough for Periscope. I'm sorry. Poor Derek. Hopefully you can catch the replay. Yes, you're welcome. So if you guys have any questions for me, I'm be very, very happy to answer. Meanwhile, I'll keep looking to see. I know there were some questions earlier on Periscope. I do know that someone was asking me about. Some people were asking for where the NOAA or the NASA version of the model is located, and that is at the ISWA website. There is a real-time run of that model, and I can't take time to type it in right now, but I'll probably put that up on Facebook for you, because I think that's where I got the question. You're definitely welcome, Bill. Thank you so much for joining in. Anybody else have any questions? Because I'll keep looking down here. Okay. Jane, Croft Jane asks, any chance of northern lights in Portland, Oregon? Yes, absolutely. I do believe that in Oregon, obviously, if you get out of the city lights, you will have a good chance of seeing it. St. Nick, this is Nick Walka, asks for Cape Cod Part 2. Yes, absolutely. Again, Cape Cod could be a good place to have Aurora. Doesn't get much better than Holiday. Thank you so much. I appreciate that, guy. Thanks, Willie. Thanks, D.A. Rudder. I appreciate that. W6CM. Greetings, thank you so much. And let's see, does this affect the jet stream? Risk Eichling is asking that. No, this will not affect the jet stream. Weather patterns terrestrial, let's see. Any predictions? I'll get to that in just a second. The types of events that we have on that are solar storm related, that are space weather related, are typically on timescales that are too short to be able to affect things like jet stream, things like terrestrial weather. Usually the way we're affected is, believe it or not, this terrestrial weather goes up and it actually affects space weather rather than the other way around. Unless you're talking about cosmic rays, and then that can affect the cloud cover, but only very minutely. No, so the question that was asked was any predictions for the next cycle. I'm expecting the next cycle will be about like this one. You're welcome, Baruch. Appreciate that. The next cycle will not be nothing. For a while there were a lot of people worried about the Maunder minimum, that we weren't going to see any sunspots next solar cycle. It looks like we will actually see sunspots. We are seeing evidence of the new solar cycle coming, but it will most likely be kind of a wimpy one, just like this one will be, or this one is turning out to be. But we are seeing some surprises with this particular cycle, things that are a little bit stronger on the back end of the cycle that we didn't expect. And there's also a very different north and southern hemisphere symmetry. Let's see, how accurate are the hand prediction charts based on solar weather? Depends upon which ones you're looking at. That's a really involved question. A lot of them aren't very accurate because they only take in like 3-hour averages or even daily averages. And some of the daily average information that they take in are oftentimes 24 to 48 hours stale. So it depends upon which ones you take in, but they can be quite off, unfortunately. Anything other than ACE useful for predicting the north-south BZ direction before it hits? Not really, other than a scientist in the loop. We are trying to do that. We've got NASA grants out right now where people are actually trying to predict BZ. I just came back from a big science conference, and the results are pretty dismal right now. We have certain models that can do it, but none of them are doing it faster than real time. And that's a real problem for us because there are a lot of people who want to do the research, but they don't care. These are scientists that they care about the physics, but they don't care about doing it faster than real time. So even if we get the right answer, the idea that it would be predictive is kind of a joke at this point. Sorry to say that, but I'm just being honest. And so we really need to, that's one of the reasons why I do this, is because if I can get you guys aware of this stuff, then we can all push for things that make a difference to us, you know, to society, and get operational things and models and predictions that really mean something and can actually make a difference in our lives. I'm visiting Los Angeles, KCONET. Oh, good, awesome. I'm so glad. Hopefully you're enjoying the weather if you come from a cold place, because it's, you know, it's not so bad here this time of year. Recommendations for really good sites for cloud cover maps has been a huge problem here lately. Oh, I'm sorry, I have no idea. NWS, the National Weather Service, doesn't do a good enough job for cloud cover maps. That's kind of strange. I don't, unfortunately, I'm not a terrestrial weather person, so I don't really know. Sorry about that. I'll mention that to a few meteorologists when I go to the AMS in January. So, okay, so let me see if there's any other. Okay, I do remember this question. Alistair Hamill asked me. He wondered why. I don't know if you guys can see this. This is the last solar storm we had. This is BZ. This is a picture of ACE data. So this is that upstream monitor that we have. This is a full day, 24 hours worth of data. And this was right when that solar storm hit, the very first one hit here. And you can see this red line. It stayed below that dotted line, or that dashed line, for a long, long period. It stayed for a good, almost 16 hours. Now, well, maybe 12 to 15 hours. So why did it stay so south? Well, actually, this is one solar storm right here, and then this was kind of an intermediate region that they were kind of mixing a little bit, and then this started another solar storm right around in this area. And the reason why we had such sustained south field for so long, which really caused a beautiful aurora all over the world, was because we actually had that. We had two solar storms, 1 and 2. And they don't really mix completely, but they do slam into each other and compress each other and cause issues, and can enhance each other and make each other stronger. So hopefully that answers the question from Alistair. And how low is the aurora going to be? I would say for this particular storm, we should see aurora, assuming the orientation of this structure is correct, so that we get some south field. That allows the magnetic field of that solar storm to click and dump its energy inside the Earth's magnetic shield. If it's pointed the wrong way, it's just like two magnets that repel each other. The storm will just bounce off the Earth and go away. But if they are attracted to each other, then they'll click together and they'll be able to kind of what we call reconnect. And the storm is able to pump all of its energy into the Earth's field. If that happens, then I would easily think that aurora could be seen. We'd easily see aurora in the upper tier of the United States. Wisconsin, for example, could definitely even see it down to New York. It might make Iowa and Ohio. It would definitely make Seattle. Definitely make Minnesota. Definitely make Idaho. Areas like that. It might make it as far south as Colorado this time, but I will let you guys know that as the storm hits, I'll get a much better feel for how the aurora, what the storm conditions are, and whether it is as fast as it needs to be, and whether or not it has the right magnetic configuration. Sorry, I meant the clouds are a problem, not the maps. Oh, okay. Oh, right. Yes, so many people this time of year have such a hard time seeing the aurora because the cloud cover is so bad. Agreed. Hopefully the clouds will be thin enough, and if the aurora is strong enough, you'll see, the clouds will light up colors, so it'll still be beautiful. So, okay, guys, any other questions? If not, I think I will bid you Happy New Year, and hopefully all of you will be able to see aurora this New Year. Again, I'll go ahead and play this beautiful structure here, and we will continue watching this structure as it continues to rotate, because we do have probably at least 5 days left of this structure on the Earth-facing disk before it disappears. Okay, so thanks a lot, you guys. I appreciate the hearts. And again, for those of you who might have been on this scope for the first time, you're welcome, Tom. Thanks, you guys. I appreciate it. For those of you who don't know me, my name is Dr. Tamitha Scove. I am a space weather researcher, and my day job, I like to help NASA, NOAA, and other government agencies prepare for the space environment. Happy New Year to you too. Prepare for the space environment and keep their satellites safe. And in my off time, I like to, oh, thank you, appreciate that cyclism. Happy New Year. And in my off time, I like to help you guys understand what space weather is, help you understand that it does affect us pretty much on a daily basis, and that it is possible to make predictions, and it is possible to see things like Aurora all over the world, and in much more frequently and in much lower locations than most people think is possible. So thank you again. I appreciate all the hearts in the 2016s. Happy New Year to everybody. And with that, I will say bye and Happy New Year. Okay, bye.